Hi and Assalamualaikum warahmatullahi wabarakatuh. And in this project, I will explain about the introduction. So, the flash floods are a significant and recurring problem in Taman University, RSC Batu Pahat. It's causing disruption to movement, damage to properties, and posing safety risks. The primary cause of flooding is an inadequate stormwater drainage system that is overwhelmed during the heavy rainfall. Urbanization has further intensified the issue by increasing impervious surface, leading to higher runoff volumes, while vegetative growing within the channels reduce hydraulic efficiency. This presentation aims to explore the key factors contributing to flash flood occurrences, analyze the limitation of the current damage system, and propose sustainable, cost-effectively improvement in complies with MSMA 2024 guidelines to enhance the flood management and long-term resilience.
Assalamualaikum, my name is Muhammad Farid Hazim and I'll be presenting the methodology for this presentation. So firstly, we have the introduction. The study focuses on Taman University Parit Raja to address the frequent flash flooding caused by inadequate drainage infrastructure. The project examines rainfall intensity, channel roughness, and urban development impacts to identify contributing factors. Data collection sources the data collection. Key data sources include topographical maps and land use information, and rainfall data for 10 years ARI obtained from GPS, channel dimensions, rainfall intensity from IDF curves, and land use characteristics are analyzed to determine the runoff coefficient. So for the third one, we have methodology overview. The rational method is used to calculate peak discharge, where Q is peak discharge and C runoff coefficient. The I is the rainfall intensity and the A is the air catchment area. Calculations follow the MSME second edition guidelines. Next, we have the channel analysis. The current drainage system lacks capacity for stormwater, vegetation, increasing roughness and reducing flow efficiency. Hydraulic modeling uses manual equation to assess the flow velocity, where R represents the hydraulic radius. Now, channel redesign. The channel redesign uses the past hydraulic section method to improve efficiency by deepening and widening channels, optimizing cross-sectional areas, and balancing flow velocity. Redesign calculation adhere to MSMA 2024 Sustainable Stormwater Management Standards. Evaluation and implementation. The redesign is evaluated by economic viability, environmental impact, and maintenance feasibility. Features include vegetative buffer zones to prevent erosion and regular maintenance schedule with effectiveness verified through hydraulic simulations and field validations. Implementation plan. A phased implementation plan minimizes the community disruptions while maintaining system efficiency. Long-term monitoring and regular maintenance schedule ensure sustainability and address existing drainage inadequacy efficiently. The project provides a sustainable and robust solution to flash flood through improved drainage design, economic and environmental assessment, and practical recommendation. Detailed documentation supports future monitoring and long-term community benefits. That is all from me. Thank you.
Hello everyone, my name is Muhammad Naim. Today I want to explain about the data of the drainage system of Taman U. In this analysis, we evaluate the drainage system of Taman University, focusing on key hydraulic parameter and design efficient. The cross-sectional dimension and hydraulic properties are carefully calculated to ensure optimal performance during storm event. The drainage channel has a trapezoidal cross-section with the following dimension. Top wide is 6.5 meter, bottom wide 5 meter, and depth 1.6 meter. So we go to the calculation hydraulic. The data of weight area is 10.28 meter power of 2, and weight perimeter is 9.28 meter. So we go to the hydraulic radius. The data of the hydraulic radius is 1.11 meter. And lastly, we go to the channel slope. The data channel slope is 4.48 times 10 power negative 4. So we go to the rainfall and flow parameter using data from the MASMA second edition, which is location is JPS Batu Pahat, average recurrence interval ARI, which is 10 and 25 years, storm duration 60 minutes, and the derived rainfall parameter are x equal 0.174, y 0.0201, and z 0.x62. From this, the rainfall intensity is calculated 1.2.46 millimeter per hour. So the peak flow is 3.16 meter power of 3 per second. So the analysis demonstrates that the drainage system is designed to manage a peak flow of 3.16 meter power of 3 per second, ensuring effective water runoff management during heavy rainfall events. The detailed calculation and adherence to design guidelines ensure the safety and sustainability of the drainage infrastructure. Next, we go to the data new purpose design of channel section. This proposal presents a newly designed channel section for optimal hydraulic performance. Using the shape with tailor dimension, the design ensure efficient flow while adhering to hydraulic standard for channel with tall grass cover. So we go to the hydraulic calculation. So the input parameter, which is the manning roughness coefficient, is cos 0.05, the data channel slope 0.0004, and the data flow 3.16 meter power 3 per second. So using the deep flow, which is 2.44 meter. Next, we go to the find top and bottom wide. The data of top wide is 5.63 meter and bottom wide is 2.77 meter. And yeah, of course, we find to the wet perimeter, which is 8.45 meter. So we go to the wet area, which is 10.31 meter power of 2. And lastly, we go to the hydraulic radius, which is 1.22 meter. So we go to the design flow calculation, which is the peak flow Q is determined using Q equals C times I times A per 360, which is the data of Q, which is 3.87 meter power 3 per second. So the temperature section with its optimized hydraulic radius, efficient flow characteristic can manage a peak flow of 3.87 meter power of 3 per second, exceeding the required flow capacity. So the new channel design improve hydraulic efficiency and ensure sustainability stormwater management while accommodating flow demand. This configuring is an ideal solution for effective drainage in the area. So that's all from me. Thank you.
Assalamualaikum. Today I will talk about discussion. So for the first point, flash flood are common in the Taman University area at Parit Raja Batu Pahat. During high intensity but short rainfall event, the computation in the project has focused on this issue in detail and has shown that many factors are causing this problem to persist. Inadequate design of an existing drainage channel is the root cause of the flash flood problem. The existing proposed channel is of shallow depth and little size, hence limiting the peak stormwater flow capacity considerably. During heavy rainfall, the water overflow the capacity of the channel and spread in the adjoining area. In addition, the information available for the second edition of the MSMA about the design does not consider the rainfall intensity of 10-year ARI. So second, the proposed solution also include consideration for environmental issue while enhancing the channel. It is possible to keep vegetative buffer zone along its edge in order to prevent erosion and protect ecological function of the area. Regular maintenance, such as overground grass trimming, will contribute to higher hydraulic efficiency of the channel and avoid obstruction. This approach corresponds to MSMA emphasis on sustainable and ecological safe stormwater management. Therefore, flash flooding in Taman University is due mainly to the inadequacies of the existing drainage channel, further exacerbated by vegetative obstruction and the effect of urbanization. Although all these problems can be overcome by adoption of the proposed channel improvement method. In this respect, the redesigned channel is guided by the principle of the MSMA, which supporting hydraulic analyze and present a practical and viable solution for the mitigation of flash flooding in the area. This solution serves to end the flooding at hand and also provide a long-term solution against my future rainfall. That's all for me. Thank you.
Conclusion. In summary, an examination of the drainage system problem at Taman University in Malaysia highlight the shortcoming of the current trapezoidal channel, which are made worse by dense vegetation and growing development. Flash flood are caused by current channel inability to control peak stormwater flow during period and intense rainfall due to its shallow depth and tiny size. By optimizing hydraulic radius and flow velocity, the suggest solution interdepending and expanding the channel using best hydraulic section approach, increase its capacity and efficiency. That's all from me. Thank you.